Hello, it is again Dr. Hakan Satıroglu. Today, tutorial 3 for business analytics. This tutorial shifts the focus from describing problems to explaining them. Diagnosis, analytics, root causes, and experimentation. I would open by saying that symptom is not cause. In business settings, people often jump to the quickly from a visible problem to preferred explanation. For example, if sales drop, someone may immediately blame price, staff, or marketing. Diagnostic analysis or analytics teaches students to slow down, generate possibilities, and test them with evidence. That is valuable professional skills because many weak decisions come from overconfidence rather than lack of data. I would stress that diagnosis is not endless exploration. It still needs to stay close to decision process. The aim is to identify the pros or causes that matter enough to guide action. This makes the session a good bridge between descriptive work and more formal testing. Students start learning how to reason more careful rather than simply noticing patterns. Session plan and learning outcome. I would like to explain that the structure of session built around the symptom, cause, and test. Students will warm up with distinguishing what is observed from what is merely assumed. Then they will work through diagnostic tools and finish with the small experimentation task. I would make clear that the learning outcome is not to find one magical root cause. It has become more disciplined in how they build an evaluative explanation. In workplace analytics, this is often where teams become political. Different departments may prefer different causes because those explanations protect their interests. That is why I will tell students to focus on evidence, not intuition, or blame. If they can leave the session knowing what to localize a problem, build several hypotheses, and design a simple test, they are already thinking much more like analysts. Here I would like to explain the diagnostic loop in language. First, we observe the problem. Then we segment or drill down to find where it concentrated. Next, we generate hypotheses about what may be causing it. Then we test those hypotheses with available evidence or experiments. Finally, we learn and decide what to do next. I will tell students that this loop is often messier in real life than it looks on slide. Analysts may move back and forth between these stages or circle. A practical example is a drop in online conversion. At first, the problem looks broad. Then funnel data may show that checkout page is a weak point. Hypotheses may include a design issue, a payment error, a poor mobile performance. The point is to make students comfortable with structure uncertainty. They need instant answers. They need logical process for narrowing the possibilities. I would introduce funnel analysis as a way of locating where a problem happens inside the process. Many of our students familiar with this funnel in the marketing lectures. However, I would like to explain that many organizations shade a whole customer journey or operational process as one box, which makes it hard to know where to intervene. A funnel breaks that box into stage. In e-commerce, for example, users may visit the site, view a product, add to basket, begin checkout to complete payment. If conversion falls, the funnel helps us to see whether the issue is broad, concentrated at one step, or in general. That matters because the action will differ. A weak product page suggests one kind of response, a weak payment stage suggests another one. I would also tell students not to stop the visual pattern. The funnel shows where the drop is, but not automatically why. So it is a starting point for diagnosis, not the final answer. This slide showing that root cause structures such as 5 whys and fishbone diagrams. I would explain that these tools are useful because they are for students to organize their thinking rather than jumping between guesses. However, I would also warn that these tools can become superficial if each branch is based only on opinion. So when teaching these, I would ask students what evidence supports each possible cause. A practical example might be delayed deliveries. Students may list stuffing, traffic, packaging time, system issue. Then I would ask which of these can be checked with data or observation. That steps changes the exercise from brainstorming into the analysis. In theory terms, this slide introduces causal reasoning in a very accessible way, but we are teaching students that plausible explanation should be compared and tested, not just listed and opined. That makes their work credible and more useful for the managers. Here, I would like to explain sometimes cleanest way to learn is to test alternatives directly. A simple A and B test compares to two versions. Even you can find that one in the Facebook or new name Meta marketing analysis. It's automatically come for the marketers. Actually, it is t-test. And two website layouts or two service scripts, variant A and variant B, could be compared. I would keep the explanation practical. Students do not need to deep statistical training at this stage, but they do need to understand that experiment needs clear hypothesis, a success metric, a fair comparison, and stopping rule. For example, if a bank wants more customers to complete in online form, it might test a shorter version against the current one and compare completion rate. I would also mention that experimentation is powerful because it helps avoid arguments based on one personal opinion, a relevant theory point could be hypothesis testing. But I would present it simple. Define what you expect, compare fairly, decide whether the evidence is strong enough to act. I would use this final exercise to make students move from symptom to action. The prompt gives them a falling conversion rate, ask them to build quick funnel, list 3 root cause hypotheses, and choose one A/B test. That is strong teaching design because it mirrors real diagnostic work. In the brief, I would ask whether their hypotheses are genuinely different or just reworded version of the same idea. I would also ask whether the chosen test is practical, not only interesting. That matters in real organization where time, traffic, budgets are limited. I would close by reinforcing that diagnostic analytics is about discipline curiosity. Students should learn to localize the issue, compare explanation, and test what matters. That prepares them well for predictive analytics, where they start to estimate future outcomes rather than explaining past trends. Thank you for listening to our tutorial.